For reasons unknown to me, it's taken me 20 minutes to get signed up. So far we have one attendee. This is not good. I'm not sure the "you pick the time" strategy recommended by Daniel is in fact going to work. In fact, I'm a little discouraged. I hope.
Let's get an automatic age being here.
Okay. Clearly, we're going to have to revisit the time of the Tuesday class. Now, nobody answered my email this morning, which asked a very specific question, which was, I have 3 subjects, and what I would like to do is fix the time. That is to say, the Thursday evening lectures will always be on quantum relativistic alchemy. No. But the Friday lectures will always be on the general relativity, on doing the generally covariant Hamiltonian description of mechanics. Nobody does that, by the way. There's one guy. It's at Santa Barbara. But there are 3 choices, and I was trying to allocate which one goes to which. At least 2 of them aren't really well suited to this approach. I'm not sure whether I want to. The 3 were: 1, lab practicum, as in how to solder, how to build cables, that one is really hard to do on Google Plus Hangout.
But I would like to learn that. That's a good, because we had that problem with the cord that they didn't like, and they went and they did it in like 2 seconds, but probably would have taken us an hour.
They actually don't like the whole idea of store-bought cables.
Yeah, well, you realize that.
And the lab practicum, coding, and then there was a subsidiary question: which language?
I would like to look at the coding that we use for Arduino and see
I don't have that.
yeah, that would be nice if Hans would give it to me. So that way we could at least look at what we needed to change to make it continuous, and what was that problem that we had that it wasn't a continuous string. I would like to look at that.
That actually is one line.
Okay.
I mean, you take out the wait 1 second.
And that's well, something like that I would like to look at. And
I mean, that's really all it is you take out the wait 1 second. Now, so coding which language? I mean, Arduino is in effect C, but it's a funky C. Don't you dare begin composing songs on that title. The third possibility is circuit design and the circuit design software. Again, that is, I'm not sure. I sure can't do it. I guess I could do it if I brought my laptop from the other room in here. Or maybe I would have to go through the process of installing whatever that piece of software is that connects directly to the electrical engineering. But also there was the question of, do we want to teach from Cadence, which would be very much a, I'm exploring this along with you because it's so weird compared to OrCAD, or do we want to work from OrCAD? That was a question. So there was sort of two levels of question. Which day for which? And what do I address in two of those classes? And I asked that this morning at about 8:15, and I have received exactly 0 answers. Well, but I understand, but your inbox just fills, you know, it doesn't.
I wake up and I go straight to class. That's pretty much how it works.
Of course, the world assumes you check your email first. Maybe that should be a 4th class, how to put email in your shower. Applying the Oxygen Lab paint to your ceiling. You all know about Oxygen Lab paint.
No.
This is rather expensive. It's like $25,000 a gallon. You paint your wall with it, and you put a special cable down one wall and a special cable down the other wall, and bingo, your wall's a monitor.
Get out of here.
Can we do that in here?
That'd be cool.
Can we do that in here?
I actually don't know if it's commercially available. I've seen videos of it at the lab that developed at MIT, but I don't. Yeah, there are two meanings. Oxygen is the woman's channel on the cable, and Oxygen is also this awesome set of labs at MIT that are about making the entire world interactive. So, you know, if I were wearing Google Glass and this was an oxygen-equipped room, I could click on one of those journals and the table of contents would appear.
Wow. Wow.
I could click on you and your weight, blood pressure, and current respiration rate would appear.
That's insane. They have all those stuff,
and the entire interior is, of course, monitor-equipped walls. So if you look at something and go, "Show me a webcam from downtown Paris," beep, that would be. Of course, I tried Siri, write proposal this year, and it didn't work. I even said please.
Because I said please. But I mean, it also kind of seems like a stalker kind of thing too, right? If you had some program like that in the wrong hands, you'd be stalking that person. Oh, she's going to Walmart. Oh, she's going to the mall. Oh, she's going here.
We're already doing that. Okay, since I actually have an audience of 2, there's no one online. And maybe I should have logged in as myself. This was set up when I started. Somebody very thoughtfully set it up for me to nominally facilitate starting the class quickly. Still took me 20 minutes to get the puppy started.
Yeah.
But it's set up logged in as USIP UH.
Yeah. All the invites. Keep invites. Or do you not?
No,
Okay.
Dr. Mexican Gerald just said he got his invite for the meeting right now.
Okay.
So it means it for now.
Okay. Well, bad. All you people who are going to be, I picked a time today, and I would solicit input. Now, Daniel Hermosillo has this table, but he refused to pick a time.
Well, the problem we're looking at right now is everybody has a problem with the time. If it's not one person, it's another, and if it's another person, it's another. But even so.
But there's a number for each hour block. There's a number. How many people are available?
So there should be enough available right now.
There should be a optimum time during the day on Tuesday or an optimum time during the day on Wednesday that could be used.
When you find out what this optimum time is, you're probably not going to agree with it, because it's usually like 8 to 10 in the morning. Then everyone is either commuting or sleeping or getting ready for class.
I'm here till 8:30 at night every day. So.
But the optimum time is based on your own input to the table.
Yes, the only input to the table was when are your classes, and that's the only factor. It's not, what time does it get here, when do you usually get here, do you have any more jobs or anything. It's one of your classes.
That's it. But still, there's a good large.
Well, okay, then you go back to, you asked this question wrong. What you should ask is, when are you available?
Yeah.
Did you go back to them with that response?
Did I tell them to ask them?
Yes.
No, I did not.
Okay, that would be helpful. It occurs to me at least that the guy asking the question is not a native English speaker, and it may not have occurred to him.
But I did say that I was not available during this.
But yet you're here.
But you should.
No, not during this time.
Oh,
It was the ordinary hours that.
But they were trying to do
it?
Yeah.
I mean,
a lot of people actually did say I am not available during this time. The group me is like filled with, well, Megan can't make this, well, Ariane can't make this, well, Daniel can't make this, and it's all over the place right now.
Yeah, but at the same time, we can't allow them to be this, oh, well, we can always just log in shit either. We need to have them here, because I still have yet to see the team when school's already started. Like, I haven't seen Megan, I haven't seen,
I see.
I haven't seen Megan at all, I haven't seen Ariane, I haven't seen Abdul.
I see. No.
We need to be able to see them together. That's the problem. We all have to be here together. So, and we
You know-
give them the excuse to go online. They just don't come in.
No.
So,
Screw the online thing. I'm just saying, like, the hours, the process for picking the hours which everyone's getting here is not very efficient.
No, it's not. It's one of those
well,
things.
okay, but if you mean the question asked was asked incorrectly. You should have responded to that immediately with that input.
It's not like it was a group kind of thing. They had meetings before school started where they got the project manager team, then you had one-on-one interviews for how your interest in the project was. And it was kind of like they told you, like, well, here are the hours. Can you adhere to this? If you can't, kind of too bad, kind of thing,
But that was based on an input into a poll table taken about 6 weeks ago.
Okay, I see what you're saying. I see.
At that point, you should have said you're asking the wrong question. Okay. It is actually kind of hard to give the lecture with one attendee coming in and out and in and out.
And we didn't hit him with the door. Like, his head was this close from getting.
Okay, we need you to sort of stay seated. It can wait 25 minutes, whatever it is. Okay. So anyway, I guess I would like input, and I'm assuming everyone's going to listen to this because I am actually talking to everybody. And you need to make sure that everyone knows that. What does work Tuesday and Wednesday during the day for class time? Because I don't have the matrix of availability. And I'm not actually terribly sympathetic to I normally get up at 10 o'clock. Yeah, okay, maybe you can adjust that. In fact, people will probably have to in order to get But the thing we learned, I mean, I'm going to quote someone sitting in this room. I learned more today than the entire rest of the project, unquote, from Friday, August the 1st. And that was because there were 9 of you in the room, and there were 9 of you in the room. And I was there. I want to talk about some observations, at least, that have some of these are all lessons learned. I honestly had no idea that you guys were in the habit of powering apparatus with this. Computer chargers or Radio Shack phone chargers or whatever. Until that fateful week before we went on the field trip, when I asked for the connection to power up the Arduino, and somebody handed me this scuzzy looking old charger. And I have discovered since that that was the problem with the U-Pod. We wasted 6 months on something that dumb. And what was the real issue? You guys with the U-Pod were working on it. You come to these meetings in this room with the U-Pod all packed up in a case and say, well, here, look at it. We're having trouble with it. As if I could learn anything in that position. You never actually got a faculty member to come and look at what was going on as you were set up and it wasn't working.
Well, we did. I mean, we had the problem with that is that it's a prototype from another school that they aren't really sure it works yet either. I mean, they said it's working, but they haven't really field tested or anything like that. So
no, that is not a reason for not getting me and Dr. Leffer to come look at it while you're having the difficulty.
Well, I tried asking Dr. Leffer to look at it and everything, and then we lost it, and then we just gave up on it. I'm building a new one because the problem we also have is that we don't know what they did before we just grabbed it. We just
no, I'm trying to make a point here, and everything you're talking about is irrelevant to the point. The point is that during the 5 months we had it, and it wasn't working. We now know why it wasn't working, because you didn't use an adequate power supply. Nobody came and got me to look at it while it wasn't working, while it was here, while we knew where it was. Nobody. Nobody came and got Dr. Leffer to do that either. And either of us would have spotted that in 10 or 15 seconds and said, no, this needs to be a DC power supply. When we started to set up for the tests, before the test flight, everybody tried to give me store-bought chargers like this. It took me a better part of a day to get across to people, no, we want to buy blanks of this type connector and connect wires to it. So there was a conceptual problem about laboratory procedure, that you do not actually want to use fixed voltage and fixed current power supplies for stuff. If you're powering something for the first time, experimental apparatus on the bench, you want to use a proper DC power supply, one that is adjustable and one where you can measure the current. And what is the first thing you do when you turn on an unknown piece of apparatus? Hint, I just told you. Measure the current. And then what do you do? No, you write it down in the notebook. It's tiresome to have somebody say, I found one of these puppies for $50, and say, okay, well, let's look at that. We might want to buy it. Oh, all I can find now is 300. Because Not because it's changed prices, because you didn't write the first one down. I don't yell at people for filling the notebook with too much information, but I get really upset and frustrated when people don't write things down.
Okay, so you're saying that we just need the tip and we can, because what we had done, we had gotten an old 12-volt wall plug and then just cut it, and they made it into a connector for the UConn that apparently wasn't good enough, or there was a problem with it, but,
It didn't have enough current capacity.
see, and that's what we didn't check. We didn't even read the current, we just got it says 12 volts, and they just put it together. Okay, it worked. We didn't check.
You never do that, okay? Those fixed voltage, fixed current supplies that have this kind of connector pre-built into them are not for the checkout of apparatus at all, ever. That's not how you work in a laboratory environment. These are for use with fully checked out, fully operational production line equipment. Okay, that's the only circumstance under which, so it's okay to use it with your laptop because you bought your laptop, but if you were putting together a home-built computer where you'd soldered all the chips in for the first time, you would not connect one of these puppies.
No.
You would connect a laboratory power supply. Actually, that's somewhat iffy because there's with most Windows computers, there's a turn-on sequence that is rather sophisticated and involves separate timings. 5 volts comes on, then 10 milliseconds later, the plus and minus 15 comes on, and then da-da-da-da. And that's sort of tricky. So you may actually want to just look at the current drain on the entire power supply at that point. Or, anyway, you have to be careful. But for most stuff, the Arduino, you can do what I said. So that's number one, is we need to start using, and number two, you guys are all checking everything out using batteries. No, you should be using benchtop power supplies. You check out the functionality of your battery stack one time before you go off to fly, but you do not waste batteries using them for checkout. And it's actually very, very discouraging to go in there and see Daniel Canales working away, testing his apparatus hour after hour with batteries powering it. That is very wasteful. We do not have to spend the money expending batteries. Now, if you have rechargeables, I guess it's okay, but you really would, it's much preferable to have things in benchtop supplies with current meters on them so you can see, oops, something's wrong when the current meter pegs. Because you've got a few seconds at that point to turn it off before things start to melt. If you're lucky. If you're not lucky, well, you got smoking bad smells. But you always start with a power supply that you control. And one of the things that's wrong with using these puppies, you don't necessarily, you have to be, I mean, when I was working with the students who kept bringing them to me a month ago, they didn't necessarily know what the polarity was. And they just sure didn't know what the current capacity was. These don't all have the same polarity. There is no default. You have 50% probability of getting the right polarity. If you plug in the wrong polarity, what you have is a dead box. How do I know this?
How would you check the polarity?
You have to unscrew it and check.
No, it is in the label. Okay? Somewhere in tiny print on this label, it tells you this is plus in the center. It's in very tiny print, and you have to look carefully. And at least one of the ones that was brought to me on Monday of the first week of test week was the wrong polarity. And whoever brought it to me hadn't noticed. And
So how would I check the polarity for like using my UPod, the UPod or
First off, you don't use one of these.
Right.
You use a benchtop supply.
And so then that wouldn't be a problem then, right?
Well,
Because
you
that
have
would
you
make
have to
my-
know what polarity it wants.
That's, how would I do that? I mean, I wouldn't.
Oh, you have to ask the supplier.
That's the people who built
Presumably, they send that sort of information to with it in some form of a minimal write-up.
But I don't really know a lot about the polarity and cords and connecting and stuff like that. That's why I asked, because I'm building our 2 pod, and then how would I? Is there a math formula or anything that I could use to figure it out or anything like that, or it's just something that it would say?
That depends entirely on how you start.
Okay.
I mean, if you're starting from absolute scratch and building and designing a circuit board, now the individual chips have a plus voltage and a minus voltage pin, and presumably when you lay out the circuit board, you connect all the plus voltages together, and you connect all the minus voltages together, and you know, assuming they're the same voltage, some chips want plus 15, some want plus 5, so you have to have 2 separate plus lines. You know what those lines are, and you know where they connect at the edge of the board. You design it that way. So, to some extent, that's a what question, because if you're building the apparatus from scratch, you've designed where plus goes in, and minus goes in, and ground goes in. Now, I think if you're being powered by an Arduino, those Arduinos are all plus, they all take plus power. But the documentation from the vendor should say. If the documentation from the vendor doesn't say, and it isn't clearly labeled, then you need to ask. There is no way to calculate. Well, there is, but it's way down and dirty in how they've oriented the transistors and the FETs and the diodes. I mean, I could, looking hard at a circuit diagram, I could tell you whether it was positive or negative voltage, but it would take me half an hour to verify it. Usually, you design out from the start, so you know from the beginning. But the real point I'm getting to is that the entire wasted 6 months with the UPod could have been spared if, as soon as you had trouble, you'd asked one of us to come stare over your shoulder. That's the real point I'm getting to.
We asked a graduate student, which shouldn't.
Okay, basic point?
Don't ever ask.
No,
Ask
no.
the professor.
First off, Dr. Leffer's group never builds hardware.
That's right.
This is new to his group. The only person around here who's built hardware from scratch throughout his life is me. I built an oscilloscope in middle school.
Wow. Okay. No, but that's it, because we were having the guidance of one of the graduate students. He never mentioned any of that stuff either, so it's kind of new in a way.
Well, but did he really actually look at the apparatus running?
No, he more like, he's the one that came up with the power cord. Actually, he was like,
Okay.
oh, we could just snap this in there and you could put it together.
And he, along
Okay.
with Megan and everybody, did that. And
No, you don't ever really want to do that. You go and you get a raw connector and you connect it to a DC power supply.
yeah, no, they were just trying to be lazy together. They didn't want to control.
So that's a real, but basically, okay, I guess to some extent you were led astray by the graduate student, but if the graduate student's advice isn't helping, then one of your steps has to be, well, let's get the faculty. I guess I'm very frustrated you guys didn't do that, because it would have taken me about 10 seconds to spot the problem. And you see, this problem has a version redux. I understand now. We need to check by reassembling everything and turning it on and seeing it works. But I understand now What happened in Fort Sumner? It's blatantly clear. Daniel tested the current drain of his Arduino. 350 milliamps. We had a 600 milliamp hour battery.
That alone drained more than half the time.
We had it sat there on the pad for 4 hours running.
Was it just the, do you just have his Arduino, or was it the entire stack?
It's his entire stack. You guys, in speccing the battery, relied entirely on the written specifications of the Arduino. Nobody has yet tested the current drain of that Arduino stack.
I was actually just setting it up.
We were talking about that earlier.
I was setting up the DC power supply.
And the other thing is that you guys had been using that battery on the bench for an unknown period before I arrived, and Hamza said he recharged it, but I'm not sure how fresh that battery was when we put it together. But in any case, since the transmitter was not set up to transmit continuously if it wasn't getting a signal, that was a mistake. And if the Arduino ran out of battery, we would never have received a signal from the transmitter.
Yeah.
That's what happened. Because the other possibilities were things like antenna being ripped off. That's intact.
Mm-hmm. Yeah, they talked about that. They were talking about soldering may have came apart.
No, I knew the next day the soldering hadn't come apart.
That soldering looked good.
No, the reason I knew that was because the transmitter batteries were fully drained.
Oh, okay. So then it did work.
The transmitter was on the whole time. The other bizarre thing that we have to figure out is that the 12-volt battery, which should not have been used up because it got used very little, was drained on both of them.
There were 9 volts, weren't they?
They were 12.
There were 12?
The 12 volts on the relay circuit.
Oh, okay.
Now, we may never use that again, but it's worth understanding why that happened, in case we do have to in Sweden.
I have to set up an either map.
Okay. See, I have to leave at 4:30 because I have a meeting at 5:30 at a restaurant in Webster.
That's fine. I have classic folks.
Let me see.
Okay. Maybe, Erica, we should have our meeting tomorrow. What's a good time?
My hours by memory.
Anyhow, so first practicum, always use power supplies. Second practicum, come and get the faculty to stare at it while the mistake is happening. Do not bring the whole apparatus like a dead cow into this room and say, this isn't working, can you tell me why? Not like that. That actually happened. You guys did that.
I'm free from 11:32.
Okay. I'll tell you what
Or we could do this again Thursday.
I'm. I think 12 to 1 is okay.
Okay.
I think. All right. Now Thursday is bad for me because I have to be in LPI at 4 o'clock. Lunar and Planetary Institute. The lunatics. Because I'm being interviewed for TV.
Ooh, what you doing?
They want to know what the likelihood was that upper atmospheric lightning took down the Columbia.
Oh, really? And what was the likeliness of that?
0.
Okay. But why would they ask you that question unless they think it's like 1% or something?
No, this is a show which is NASA's Mystery Files.
Oh, okay. No, that's awesome.
And NASA would send a photograph of the Columbia. Looks like it was hit by a lightning stroke. Actually, with the camera jiggle.
Really? Okay.
The and I was part of the investigation. I ended up writing a 50-page report on all the things the upper atmosphere could have done that it didn't.
Could have, should have.
That was actually fun. During that period, I could call up anybody. Say, I'm with the investigation. Can you give me your data for blah, blah, blah? Sure. Where do I send it? No questions. Classified, doesn't matter. Okay, yeah. But the other issue here is, and I've got 3 minutes, so I'll finish. And hopefully, it won't take me 20 minutes to log in next time. We need to get way farther ahead of time on ordering parts. In particular, ordering all the little parts no one even thought about. You know, when you have a block diagram, is there a block diagram behind me? No. Okay, if you have a block diagram and you see there's a line between two of the blocks, that line is a cable, in all likelihood. The cable is going to have 1, 2, 3, 4 connectors, 2 of each polarity at the ends. It may even be a self-adapter in that it has a edge connector on one end and a 9-pin D on the other. You need to make sure we have all those connectors. If I'm getting close to the end of my supply, replenish. And then those connectors come with accessories, locking hardware. Now, I'm pretty sure, actually, I had the opposite sex of the locking hardware somewhere in my cabinet. You just didn't look for it. We hadn't gotten it out.
For which?
For the Canon Ds.
Oh, I was looking for the Westinghouse ones. I think I found them though.
Locking hardware, potting shells, and all that noise. And part of the problem is you guys are not really conceptualizing where to shop. We are original equipment manufacturers. You shop in the wholesale market. Newark Electronics. And so there's an awful lot of stuff there that you can't find at Fry's or EPO. But it takes a couple of weeks to come. So you got to be ahead of the game and identify all the connectors you're going to need. And yes, you do need a circuit diagram for the wiring harness. You now know that. Wiring harness. When you're building a wiring harness, you put the payload together. You physically have all the bits where they're going to be. And then what you do is you run 1 wire worth of the cable and give yourself 5% extra. Cut that length. Then cut all the different colors that length. Then build the cable. Now, you probably will have at least one cable, one place where most of the wires come together. But some of them will be point to point without going to the central point. So we have the wiring harness, everything that connects to the shorting plug, and then there's that one cable that connects the Arduino to the transmitter in the present configuration. So you'll have combinations like that. You need to get those connectors in advance. I remember about 3 weeks before the flight saying, "You guys ordered your connectors?" And having all of you stare at me like I was something that had crawled out from under a rock. I knew what a connector was. And Rachel said, "You know, we're so used to having cables be provided when you buy something. And, okay. The ones that came were very heavy, and NASA wouldn't have allowed them. Um, so, and some of those connectors, we may have to find some faculty member who has a good fab technician and pay him a little bit to build them or teach you to build them. My own view is every physicist should know how to build BNC cables. I'd like to try. There's a reason I'll be challenged. That and arthritis in my hands, and you're fabricating, you're doing things like cutting the insulation off to the nearest 16th. Okay, so we need to get way ahead of time in having all the connectors we need, and having and the last thing I wanted to say before we go in the other lab and burn things up is you tried on lace cord, but do you know what you actually got? Shoelace cord. It's way thicker than real lace cord.
I literally walked up to the guy and was like, "Do you have a lace cord?" He pulled out went into the drawer and pulled out and tossed it at me. I was like, "Okay."
That's why we need to order ahead of time from Newark. And I really don't know where. Somewhere I had, and I suspect that a year ago when Diego and Daniel and Rachel were helping me, and some of the rest of you were helping me unpack and clean up, we put it all in a drawer because I had 4 or 5 rolls. And I said, guys, put things where you'll know you'll be able to find them. And
Don't know what everything is. Still don't know what everything is.
Yeah, and at some point maybe we need to go over the list of lessons learned. But I really wanted to talk about the whole idea. The key idea here was there were moments when you needed to have asked for help that you didn't. And recognizing that a graduate student who's never built a piece of apparatus in his life might not be the best source.
No, we assume that they know more than we do because they're where they're at, and it's not true at all.
Okay, can we have an attitude adjustment here? When I was an undergrad, went to work in a lab, I considered it my mission in life to prove that I was better than all the graduate students. I didn't tell them that. That was my approach. It's a good approach.
I don't know if we can do that, Dr. Brown.
These are U of H graduate students. I was up against Harvard graduate students. Yeah, like several of the students that I was trying to show up are now in the National Academy. And one of them I had breakfast with a couple of years ago. He said, you were working really hard. I said, yeah, I was trying to prove I was better than you. He said, good luck with that. He said, I kind of thought that was it. I didn't say anything because I knew that was at least that was going to produce good work product. So questions before we go next door? Okay, so how do I turn this puppy off? Now somewhere there's a leave. No, that wasn't it. Okay, there has got to be. Oh, there it is. Hang on.